In today's video, we will set up a Postgres database and run it inside Docker. This database will be available for other services we self-host so they can connect and use it easily. We will also deploy pgAdmin in Docker, which will allow us to manage the database through a web interface. Let's get started and see how to set everything up step by step. This virtual machine is ready with Docker installed. I have mounted 2 storage shares from my TrueNAS server, one with iSCSI and one with NFS. If you want to see the setup process, check my earlier videos from the I button in the top right corner. I usually store my Docker Compose files on the NFS share, so I can deploy containers from any VM by mounting the same path. You can even bind container volumes to it for easy migration, though NFS is slower and may have permission issues. It is fine for files like Docker Compose or some container volumes, but for Postgres volumes, it is not recommended. We will use iSCSI instead, but remember it can only be mounted by one machine at a time, so plan accordingly. Now let's create the Docker Compose file for Postgres. I will go to the NFS share and make a directory named Docker. Inside it, I will create another directory for Postgres. Then I will create a new Docker Compose file in that folder. We will start with the services section and name this service Postgres. Next, we need the correct image. I will search Google for Postgres Docker and open the Docker Hub link. From here, we need to copy the image tag. But for databases, it is not a good idea to use the latest tag because it can change with updates and cause issues. It is safer to use a fixed version. Right now, the latest tag points to version 17.5, so we will use that. I will go to the Tags tab and find version 17.5. You will see an Alpine variant as well, which is a minimal, lightweight version. For this setup, I will choose the standard 17.5 image. I will copy the full image name and paste it into our Docker Compose file. I will also name this container Postgres. Now, we need to define a few environment variables to configure the database. I will go back to the Overview tab and scroll down to the Environment Variables section. We will use these 3 basic environment variables and add them to our Compose file. You can always add more environment variables based on your needs, but these 3 are the basics. Now let's set their values. I will start by entering a strong password. For the username, I will use my name. For the database name, let's use Postgres. This database will be created automatically when the container starts. Later, we will create dedicated databases for each application. Next, let's map the ports. I will map port 5432 on the host to 5432 in the container, since that is the default port for Postgres. You can use a different port, but I prefer to stick with the default because many client applications expect it and sometimes don't allow changing it. Exposing the default port is not ideal if you want to expose it for remote access. But in this setup, everything stays within the local network, so it is not a concern. If you know any best practices about this, please share them in the comments. In my setup, all containers run on the same VM and connect over Docker's internal network. That means I can skip exposing the port to the host for now. I will comment it out, and if I need to expose it later, I can just uncomment it and redeploy the container. Now we need to define the volume where Postgres will store its data. I will use the iSCSI share for this. I will copy the path to the iSCSI mounted storage and create a folder inside it called PG Data. This folder will hold the actual database files on the host machine. Back on the Docker Hub page, you will see that Postgres expects a persistent volume at a specific path. I will copy that path and add it to the Docker Compose file as the container side volume path. Next, I will set the restart policy to unless stopped. This ensures the container restarts automatically after a reboot, unless we stop it manually. That's all we need to define in the Docker Compose file for Postgres. Now let's save the file. I will open the terminal in the folder where the Compose file is located to make sure we are in the right directory. To start the container, I will run docker compose up-d. This command will pull the Postgres image and start the container in detached mode. Once the container is up and running, let's check the iSCSI directory. Here, you will see a folder named PG Data has been created. This is where Postgres stores all its data. At first, it might look empty because of permission restrictions. So let's open the integrated terminal in the parent iSCSI directory and run ls to list everything. As expected, the PG Data folder appears. But if we try to change into it, we get a permission denied error. This is normal because the folder is owned by the Postgres user inside the container, and our current user does not have access. If we run sudo ls pgdata, we can see that Postgres has already initialized the directory with all the necessary files inside. There is no need to change anything inside the data directory. I just wanted to show you where your actual database files are stored. Since all data is stored on the iSCSI share, it is safe. Even if the host machine is lost, you can mount the drive on a new machine, recreate the container, and everything will be just as before. Now, Postgres is up and running. If you check the logs, you will see it is already listening for connections. Next, let's set up pgAdmin to give us a nice graphical interface to manage our database. We can define the pgAdmin service in the same Docker Compose file as Postgres. Here I'm using pgAdmin just as an example for any other container that might connect to this Postgres database. The problem is, if multiple containers depend on it, we can't really keep them all in one file. Every time we update one of those other containers, Postgres would restart as well, and that means downtime for every application using it. That's why I will show you how to keep pgAdmin in a separate Docker Compose file. You can do it for any other container that will require to connect to this Postgres database. This way, Postgres stays up even if we make changes to other containers. This solves the issue, but it does introduce another challenge. You won't be able to use the depends on parameter in Docker Compose. So we just have to make sure Postgres is running before pgAdmin starts. So now I'll create a separate directory for pgAdmin, and inside it, I'll create a new Docker Compose file. We'll start by adding the services parameter, and then define our pgAdmin service name. Now for pgAdmin to connect to Postgres by hostname, both containers need to be on the same custom network, not the default bridge. In the terminal, first type docker network to see all the available commands. Then type docker network ls to list the networks. We already have the default one for Postgres, but let's create a new one by running docker network create, then the network. You can use any name you want. I will name it Postgres. After creating the network, let's check again to confirm that our new Postgres network has been created. Now in the Postgres Docker Compose file, add a network section, mention the name we provided, and set external to true so Docker uses the network we just created. Then in the services section, add networks, then the network name. Now run Docker Compose up -d, and the container will be recreated. If you still see the old default network in the list, simply remove it and you're done. Similarly, we need to do the same thing for the pgAdmin Docker Compose file. So I'll start by copying the network section from the Postgres file and pasting it here in the pgAdmin file. Now let's define the rest of the configuration. First, we need to mention the image for pgAdmin. For that, I'll head over to Docker Hub, scroll back up, and search for pgAdmin4. You'll see an image named dpage/pgAdmin4. This is the official Docker distribution. Let's check the latest version, which right now is 9.5.0, and copy that into our Docker Compose file. Next, we'll give our container a name. After that, we need to define some environment variables. I'll go back to Docker Hub, return to the overview page, and from there open the link to the official documentation. Under the documentation, you'll find all the details for deployment. Select the version we're using, then go to Getting Started, Deployment, and Container Deployment. In the Environment Variables section, you'll see a list of available options. For our setup, we only need 2 of them. Remember, these values are for logging into the pgAdmin web interface, not for connecting to the databases. Now let's set up the volumes. You can use an NFS share or any storage you prefer. There's no limitation. I'll bind a volumes directory right next to this Docker Compose file. To know where to map it, we'll check the documentation again under Mapped Files and Directories. This gives us the exact directory path to use. If you're doing a more complex setup, there are more options available, but for now, we'll just use this one. Also, in the warning section, it says we need to change the ownership of this volume to user and group 50/50. So I'll copy the directory path, paste it into the Docker Compose file, then create that volumes directory and change its ownership. I'll open this location in the integrated terminal and run sudo chown-r 5050:5050 followed by the directory name. Now we'll expose the port 8080 from the host to port 80 inside the container. We'll also add this container to the Postgres network, set the restart policy to unless stopped, and with that, we're ready to deploy the container. So in the terminal, I'll run docker compose up-d. This will pull the image, and in a short while, the container will be up. If you check the volumes directory while it's running, you'll see files being created. Now we need to access port 8080 in the browser, but before that, let's check the IP address of this virtual machine. I'll type IPA, and here's our IP. In the browser, I'll enter the IP address followed by a colon and 8080. If it doesn't load right away, that's fine. The container is probably not up yet. This delay usually happens when using an NFS share because it's slower. It will only take longer to the very first time, and after that, it starts quickly. You can also check the container logs to see the progress. Once it's up, we can log in with the username and password we set in the environment variables. I'll log in now. And we're inside pgAdmin. First, I like to switch to a dark theme so it's easier on the eyes. We can do that by going to File, then Preferences. Under the Miscellaneous section, select User Interface. Here you'll find the option to change the theme, so I'll switch it to dark theme and click the Save button at the top left. Now it's much more comfortable to look at. Next, let's connect to the Postgres server. Select the Servers option, right-click on it, and choose Register, then Server. Here we can give our server a name. After that, go to the Connection tab. If you're hosting pgAdmin from a different machine, you can directly enter the IP address of the VM. But in our case, since both containers are on the same network, we can simply use the host name, which is Postgres. The username here will be tech. This is probably taken from the email we set earlier. And for the password, we need the database password. I'll copy it from the Postgres Docker Compose file. I'll also choose to save the password so I don't have to log in every time. Then I'll save the connection. Now we have full access to the database and its tables, and we can use it for any services that need a database connection. Now, if you want to deploy a service that can make use of this Postgres setup, make sure to watch the next video. Thanks for watching.